Now let's talk about the workflow in reinforcement learning and see how the different components in a reinforcement learning problem interact with each other. So in reinforcement learning, we have the agent, we have a state, we have action, we have environment, and we have rewards. What happens is the agent, which I want to reiterate again, is the piece of code that tries to solve the given problem using reinforcement learning. It is not very wrong to think of a robot or whatever the agent controls as the agent, but technically the agent refers to the code. Okay, so I'm going to use a self-driving car as an example to explain this workflow here. So the agent here is a piece of code that runs on the car. You are not very wrong if you say a car. So what happens is the agent is first of all going to start by sensing its environment. It is similar to how human beings drive. You don't just sit in a car and begin to drive off. When you sit in a car, you check to see that there's no one in front of you, and then no car is too close at your back, no motorist or someone on a bicycle is in your rear view mirror, or you do certain checks. It is sensing the state that you are in. So the state is the instantaneous representation of your environment, the agent's environment. So for a self-driving car, some of the things that it will want to know in its state is, am I close to a traffic light? If I'm that close to a traffic light, what is the color the light is showing? Is it showing red, yellow, or green? Am I close to a human being? Am I close to other cars? Is the traffic light opposite of me green, such that the other cars are going to cross? These are all things that the agent has to sense, and that is why in the robot we added a sensor to be able to sense how far away we are from a block. And after this, I'm going to use the robot to explain this same flow for you to understand how it fits together before we go to writing the code. So the agent is going to sense its environment, and it does these in time steps. Okay, you the implementer or the programmer decides how long a time step lasts. Let's say every second or even a microsecond. So what happens is, at any point in time, the agent will start in a state, and the state it obtains from the environment. So a state is represented, the environment is represented by a state. Now over here, I'm going to assume that my agent starts in state ST. That's the current state, okay? So in state ST, it has sensed everything that is important as far as the task at hand is concerned. So the agent senses all the measurable parameters of the environment and keeps it in a state. Now, based on that state, the agent is going to take an action in the environment. Okay, so the agent senses the state, and based on that state, is going to take an action against its environment. And what you need to note is that every action the agent takes changes its environment. Now, let me help you with the environment. So the environment you can simply assume to be anything that is outside of the agent. So in a self-driving car, the agent is a source code running on the car. So anything outside the car, you consider it as an environment. So the other people driving around, other cars, the state of the traffic light, is there a speed limit sign, and all those things, they are all in the environment and they are encoded into the state. So with knowledge of the state in mind, the agent's job is to take the most optimal action, the best action. And how do you know if this is the best action? It depends on something called rewards, which I'm going to get to. So the agent senses the state, it takes an action, and every action it takes changes the environment. For example, in the state, I mentioned that the car might want to know how close it is to the next traffic light. Now, if it moves forward, it is now even closer to the next traffic light. It is now even closer to the next human being who might be crossing. So the environment has changed. That is why in reinforcement learning, the agent needs to keep sensing its state or sensing its environment, and then taking the best action, the optimal action. So it takes an action in the environment, and what the environment does is to give it a reward and the new state. So the agent is going to sense that I have moved 1 meter, and so I am 1 meter closer to the next traffic light that I sensed. And the reward is going to be, did I cross a traffic light? Did I knock a human being? Did I run into other cars? Or I avoided all these uncomfortable situations and I'm in a very clean state where nothing bad has happened. So the reward is just a number, and it is purely based on you, the developer, to design your reward system. When we write a code, you will see what I mean. But you can choose to say +1. I give the agent +1 anytime it takes the optimal action and it avoids everything that is considered bad situation. In a story of the self-driving car, bad situation is running into other cars, crossing traffic light, or doing anything that is not considered roadworthy. Okay, so if it doesn't do any of these bad stuff, and you might ask, how will you know if it did any of these bad stuff or not? Of course, the agent always has sensors. Like human beings, we are always sensing with our 5 senses. We are always sensing our environment, and we are taking the most optimal action. Okay, so the agent gets a reward from the environment, and it also senses the new state that it is in. And then it goes back to taking an action, changing the environment, getting a reward, and the new state, taking action, sensing, changing the environment, getting the reward, new state. It repeats this over and over and over as long as you permit it to run. And the beauty of reinforcement learning is that as the agent keeps completing this loop over and over and over, it becomes better and better and better at performing the optimal action. I remember telling you that reinforcement learning is cheap. However, in the context of a self-driving car, the cheapest thing is not to build a self-driving car and just put it on the road that learn how to drive. It doesn't work that way, because once you put it on the road, it is dumb, it knows nothing, because it takes a long time to train it. So it will start by running into other cars, which will be costly. It will start by breaking traffic rules, which can be costly, or even make it difficult for authorities to allow you to use your self-driving car on the road. So for scenarios like this, we have an environment where you can actually simulate. So if it's a self-driving car, good folks have written great environment where you can have your car on the screen. You write your code, that is the agent, and you set the car off in a simulated 3D environment so that the car will start by running into things, knocking down, getting all the negative rewards, and as time goes on, it will learn how to optimize for the positive rewards. So the goal of a reinforcement learning agent is to figure out what is the best action for me to take based on the rewards that it gets. If it gets a positive number, it takes it as, oh, this is a good action, it is pleasurable, so it reinforces that action. And if it gets a negative reward, a negative number, it knows that this thing is a bad thing for me to do. Sometimes they will associate the best action with a state. So the best action will be state dependent. For example, if I am at a traffic junction and the traffic light is red, the good thing for me to do is to stop. However, if it is green, then the best thing for me to do is to drive. Okay? Because if it got to the red traffic light and it drove off, you have to design your system such that it will get a negative reward. And you can distinguish between different rewards by increasing or reducing the magnitude of the reward you give it. So if crossing traffic, breaking traffic rules is a no for you, then you can give it, let's say, -10 for doing that. Okay. However, if there are less punishable offenses, you can decide to give it -1, -2, or even some smaller number. Just make sure there are differences between your different punishments. For negative rewards, it's okay to call it a punishment also. So what happens is that it will learn the best action to take in every state that it finds itself in, so that it will optimize the reward that you want it to have. So this is basically a rough overview. I know it might not be so clear to you, but thankfully we have a robot here and we are going to write code to be able to, solidify this whole concept in our mind. Okay, so in the next section, I'm going to explain to you how this thing works in the context of the robot before I will talk to you about the specific algorithm, because reinforcement learning has a lot of algorithms, and we are going to implement the simplest reinforcement learning algorithm over here, and it is still going to be able to let our robot learn how to take optimal actions based on the reward system that we design into it. So in the next section, I'm going to explain to you this whole thing in context with the robot.